Thank you, Rob. Our final session of the day is a panel discussion discussing the benefits and trade-offs of different emissions reduction solutions. I'd ask our panelists who know who you are, and I'll introduce you in a moment, to please come up and take a seat. An observation from someone who has followed the development of emissions technology since the early 1990s, dating myself a little. I don't think things have gone exactly the way a lot of people might have expected them to. Some of you may be old enough to remember when there was actually a controversy about the use of EGR. One engine manufacturer, who shall remain nameless, claimed that it was bad for the engine because it introduced contaminants back into the engine intake manifold, a concern that another company's chief technical officer dismissed with the comment, "Where do they think it came from?" Some people have had similar objections to diesel particulate filters, saying you're going to have use a lot of fuel to regenerate them, or if you don't regenerate them often enough and then try to regenerate them, you're going to start fires. There was a kerfluffle about the concept of SCR. How are we ever going to apply that to vehicles and equipment? Where are the people ever going to get diesel exhaust fluid? That came home to me what a chimera that was when at a local Blaine's Farm and Fleet I saw the special for DEF, $9 for a 2-gallon jug. But fear of the unknown drives a lot of foolishness, and all of those technologies have managed to be deployed safely and successfully over the last few years. What's also interesting to note that while there are a lot of similarities between engine and aftertreatment systems offered by different manufacturers, there's still a lot of variation in terms of how they're applied. Some manufacturers, as we have noted, and they won't be able to do this very much longer, but have managed to meet Tier 4 final without the use of a DPF. Some manufacturers have managed to eliminate EGR. Most still use it in some form. Some manufacturers have managed to develop the single module aftertreatment systems we've heard about. Some suppliers still go more into a modular, put the pieces together kind of approach. Clearly what this means is, particularly on off-highway equipment, this is a stew that can have a lot of different ingredients, all of which have their strengths and weaknesses. And that's what we're going to be talking about here. And I have the pleasure of being your moderator, and as part of this panel, would like to welcome both familiar and new faces. One of our panelists is Jamie Jackson of Cummins Emissions Solution, who you heard a short time ago. Joining Jamie in our panel is Dave Satola, Director of Regulatory Affairs for Johnson Matthey. You can say hi, Dave. And Dr. Deep Bandyopadhyay of Progress Rail, a Caterpillar company. Dave leads Johnson Matthey's U.S. regulatory activities with responsibility to oversee policy strategy for the company's emissions control and sustainable business technologies. He leads Johnson Matthey's engagement with legislators, officials, policymakers, NGOs, and industry stakeholders impacting energy, climate, and environmental policy. I don't envy you your job with that. Prior to joining Johnson Matthey, Dave served as Director of Regulatory Affairs for Hess Corporation's Energy Marketing Business and Assistant Attorney General in the Massachusetts Attorney General's Office Energy Division. At Progress Rail, Deep currently serves as New Product Introduction Lead for Tier 4 engine development and for marine and power product application. Thanks to our panelists. First of all, I would remind the audience that you are encouraged, this panel is up here basically for you, so you're encouraged at any time to ask questions of our panel, and they're really here for you, so don't be shy. But since no one's ever accused me of being that, I'll start by asking a very basic question. Since the subject here is to talk about the benefits and trade-offs of different emission solutions, what do you identify as benefits besides the obvious of cleaner air and it's what the government's requiring? What do you tell a customer when he asks you about the benefits of this? And I'll ask each of our panelists, whoever wants to start, how do you identify benefits to a customer?
Yeah, well, I mean, obviously our customers are here, so a lot of that is obviously regulatory driven. So we're a step removed from the end use customer, but we certainly understand a lot of those challenges that they have to answer, and we're there to support them in that effort. A lot of those questions really come to these guys, not us.
Um, One thing, when you look back in the tier two and a little bit in the tier three, we were meeting the emission numbers by pretty much reducing the thermal efficiency of the engine, retarding the timing. When you're going to tier four, one of the thing by using an after treatment system, you can get some of those thermal efficiency back. Some of the customers are quite excited of that, but obviously there is a price they have to pay. The DEF cost is not proportional to what the fuel cost is, so that sometimes helps. Right now it's not in favorable, but when the diesel prices go up, it definitely helps more making those cases. So that's, I think, one benefit definitely. There are a lot of our customers who want to label them as green, and anytime when we, and basically their overall fleet emission numbers, they need to bring it down to a given number. So that sometimes helps quite a bit of. So.
Jamie, you identified before. You said, nobody wants us there, but it's good to be needed.
Yeah.
So when you're, you either look at OEM customers or end user customers. How do you identify benefits to them?
Well, I did also mention the idea of limiting the pain that the customers would see on taking on some of the new technology, because it does have to be there. When Tier 4 final, we're able to get most of our customers to meet the regulation without a DPF, without the need to do regen. Every little bit helps. I know with a lot of what we do, adding the DPF, for instance, does give us an opportunity to have better transient emissions or transient capability, that you're able to capture some of that transient smoke, and that is something that, it doesn't outweigh adding a DPF and everything that comes with it, but it is something that can see as a benefit from having some of the technologies there.
One of the things, Tier 4 final particularly, was one of those kind of regulations that it quote, officially went into effect for most of the horsepower bands basically in 2014. But because of the flexibility offered to OEMs and engine manufacturers through the TPEM program, the FLEX program, it's fair to say that there are a lot of segments of the machinery industry that has not had a lot of experience with Tier 4 final technology. For those that have, and there are some that have, there are more Tier 4 final machines getting out in some segments than others. What's your understanding of their overall acceptance and their experience of working with Tier 4 final engines and or equipment? Whoever wants, we'll start off with anybody.
Well, everybody's looking at me over here, so we, I guess, spoke around lunchtime that, being a pessimistic engineer, no news is usually good news, that there hasn't been a lot of complaints coming into the new product development teams for things that we need to try to quickly address or improve upon as we go into stage 5. So it seems to be an indicator, at least the core technology and how we implemented it is at least working as we expected. I'll admit I don't know what volumes we have out there today and how that compares against Tier 4 interim. As far as some of the challenges, this may be more from on-highway, but I know, when it comes for like a DPF-based regen, if you have that type of system, which we do in our 12 and 15 liter, you have indicators of soot loading, indicators that tell you it's time to do a regen, and we do have, in a lot of cases, an inhibit switch would prevent you from doing a regeneration. If for some reason, if you're right next to a fuel depot or something like that where you shouldn't be doing a regen, you can do that. And I do know there are cases where the inhibit switch was left on, and it just finally ran until it plugged the DPF and had a service event. So those type of things do still happen on occasion out there.
Dave, what's your experience? What are customers, Tier 4 customers, what kind of feedback are you getting from them?
Yeah, man, a similar experience to Jamie. We're not hearing a whole lot of complaints about how the technology is working, and we're still in discussions with them on their next generation system, so we take that as good news.
And Deep, on the rail side.
I think for the rail and also for the Category 2 marine, we kind of just have entered the Tier 4 final. So I think we are still on the learning phase of it. The customer always is very concerned. Everything we closely work with our customers to make sure that we are together in the learning curve. So I think we need a few more time before we have the entire learn the entire process.
Do you think, another question for all of you, one of the things that has struck us over the last year or two, and if you're a reader of Diesel Progress, you know we've been talking about emissions since the late 1990s, and the engine manufacturers and the OEMs have been talking to their customers about the various emissions level in Tier 4 final and things like that. Yet we're sort of perceiving that there is a disconnect there, that somehow the message hasn't fully gotten through. There's not a lot of understanding of what the proper care and feeding of Tier 4 engine and after-treatment systems is. I guess, is it just going to take experience to have that change? Or because I think the industry, you know, I certainly know the engine manufacturers, I certainly know the equipment OEMs have tried to make that point to their end user customers. And for some reason, the impression I get, and maybe you can tell me something different, is that those messages have not been fully received. What's your feeling on that? Are we just hearing from the people who are complaining, or is there still a lot of misunderstanding?
I can just one example from the marine application. There are a lot of players in the entire marine application. You have the naval architects who is designing the boat. There are shipbuilders who are making the boat. There are engine OEMs who is building just purely the engine, and then you have the end operators. And everyone wants to make sure they are not responsible for any of the compliance. Everyone wants to make sure that regulatory perspective, they're always on the up to date. So that's one thing which I have felt talking to a lot of our customers. They want to know, and that information. If you're on the locomotive side, since we make the locomotive, we have the entire compliance portion of it. But on the marine side, that's a slightly different, and I believe Cummins might have a very similar experience where someone else is taking the product and integrating in their vehicle. So that's one area which we feel the customer is really concerned, especially how the data is logged, how do they report it back to EPA, what are the things they have to do. That's one area we at least have hours of discussion with our customers.
Jamie, have you found that pretty much to be the case too?
Do you mind just restating the question a little
Well, I
bit
guess
to make sure?
you know, he's saying that it's sort of an educational process with the customers back and forth, and I guess various customers will be at various places at various times. I guess, what are you finding?
Yeah, that definitely makes sense to me. I can say I'm, the engineer who on a family trip in Luxembourg, I couldn't get the fuel nozzle to fit the car, so I just let it trickle in, thinking it had to be something that was wrong in the Netherlands or in Luxembourg. So even if they have the knowledge, when they go to apply it, they may just really not pay attention or recognize it until they run into a problem or really see it.
Anything you want to add, Dave? Okay. What are the expectations of continued improvement in emissions technologies that we've seen so far, like the DPFs, the DOCs, the SCR systems? There was a sense, at least on some people's part, that when we first got to, when those first started to be implemented, okay, the job was just hit the standards. And I think a lot of people mistakenly thought that development was going to kind of, okay, we've met the standards, we can go on and focus on other things. And I guess, are there other opportunities in continuing to develop things like after-treatment systems and how they integrate with engine systems, and what might those be? Dave, go ahead.
Yeah, I mean, yeah, absolutely. There's a lot of opportunity, and our customers demand it, that we continue to innovate. I think we've seen volume reduction, optimization go from the light-duty market to the on-highway market. I mean, Jamie talked about how they evolved the single module on-road 2017 system for their stage 5 system, where there's significant volume reduction there. And Tier 4 final is a big reminder to our industry that EPA standards are performance-based. And we need to continue to innovate because there's some really smart guys on the engine side who are also going to innovate to try to find a way to meet the standard, and reduce costs. So, DPFs came off, certain engine families, and that's a constant reminder that we're not just competing against our direct competitors, but competing, with others in the, supply chain to make sure that our technology remains cost competitive.
And even the engine manufacturers, like the two guys sitting next to you.
That's right.
Jamie, Deep, what do you think? What are the opportunities? Is there going to be continued development? And I guess, how do you see that going?
There's definitely continued development. David just mentioned cost, and we talked a lot earlier about size. Really, the other branch of that's quality. So what can you do to continuously improve the quality, cost, and reduce the size? What I spoke a little bit earlier about single module and the experience we're having with non-EGR technology, we knew that system had to grow versus what we have in our EGR-based product that's for on a highway. So, the next step there is to see what we can do to slowly develop that technology to reduce that size again, to try to get into that smaller space claim. So that's one thing, even without any type of additional emissions drivers, that we would need to do. Obviously, from a cost perspective, that's always going to be a strong demand to further reduce cost. But I think, moving forward, it's probably going to be more on the system side that you'll see the development. Because where we may, make the system much simpler by removing EGR, it makes the aftertreatment more complex. Or if we do more with the engine, it makes it less complex. And that balance and trying to find the right balance for customers, transient response, emissions capability, cost, the total cost of ownership, fluid economy, all those things will be there to try to continuously optimize as we move forward.
Deep, you have any?
I think Jamie and Dave pretty much covered most of it. One other thing I want to add is reducing the weight, overall weight. A lot of our applications, that's kind of getting one of the weight and the size is what's kind of getting the limiting factor, packaging it into, so basically having a smaller after treatment with a similar conversion ratio, what we are expecting from, so for the same space velocities, if we can use the less number of bricks. Now, one other thing is that especially for the large engine side, your life expectancy is quite high. There are a lot of locomotives and engines that are still running, which were installed or made before I was born. Now, what do we do with any after treatment system which we are putting? How do we ensure the life expectancy of those? We pretty much kind of throw a dart at it right now and expect it to run, and we do some running and extrapolate based on that. There must be some better tools for us to predict the life expectancy, and these are, I'm talking about 10, 15, 20 years down the lane. So that's something we have to do.
I guess, Jamie, your mention of cost brought to mind another question. You all work for global companies, and we all look and see how different regions are adopting different emission standards at different times. But I think we'd all agree that the movement is forward, and eventually, while it may take a while, there's going to be more similarity. There will almost be global emission standards that you have to meet. The challenge, I guess I would think for you, is you can't just take something that you manufacture in the U.S., take it to China with those kind of costs, and just graft it on and make it a solution there. How do you play that global game as far as making the economics fit what the local markets are? What are the challenges there to be able to bring similar technologies, because you're trying to get to the same result, but let's face it, you could not sell a single module after treatment system to Lugong for the same price probably that you could sell it to a Terex. How do you address that sort of thing?
So one of the general terms you'll hear used within CES especially is fit for market, having the right technologies for use at the right time in the right market. So where we may have taken an SCR-based technology for Euro 4 that was launched successfully in Europe and tried to move that into India, we found the use of a partial flow filter may be a better fit for that market, both from a cost and usage perspective. So whenever we are trying to develop our technology, like the core building blocks, the Lego blocks, are such that we can pick and choose and try to adapt those as necessary for each of the markets we work in. So the single module, that may be a key question. Will you see that in China in 10 years from now? A version of that, I don't know. So that is one aspect that we try to do. And then obviously with development, like a lot of industries out there, we have a global development center in India. We have a facility in China that I actually will be visiting next week. And we do a lot of local development, that helps cut down on the development costs, reuse, reducing proliferation. Those are all things that help benefit us when we try to take the technologies and expand their usage across the globe.
I guess, Dave and Deep, how do you, again, you're global companies, how do you accommodate for the very real differences in what the markets will bear? They want similar technologies, or they're going to need them, but again, the economic standards are different. How do you address those sorts of things?
Not only internationally, even domestic, we have different solutions for a rail market and for a marine market. I agree with Jamie on, so you basically take a step back and evaluate what are the different technologies available for that particular emission norms. For marine, IMO 3, you have relatively stricter NOx, but there is no PM regulations. So you see which technology will be the most optimal at that point, and your solution needs to be modular enough that you can accommodate any changes in your solution. But not only that, even over North America, we have an EGR solution for the railroad and a urea solution for the marine side, and that's because what the market needed at that point, or needs at that point.
Yeah, I agree with these guys. Innovate. In our business, PGM thrifting is not going to get to the price point to be cost competitive in Asia. So we have, like Jamie mentioned, we have innovation centers in Asia to try to figure out how to effectively, reinvent the solution to come at a price point that can be competitive with a whole new suite of competitors that we haven't run into in North America and Europe.
How effective have both the component manufacturer community, the engine manufacturer community, and the OEMs, how effective do you think they've been in communicating how to properly operate and maintain, let's say, Tier 4 final equipment? We've heard a tremendous number of horror stories about guys continually hitting the delay regen button until the machine absolutely won't run, and then complaining about that afterwards. The best one I heard was very recently about someone who was refilling the DEF tank on a piece of off-highway equipment out of a boot where they had poured the DEF in and were pouring it and things like that. And I guess we've seen any number of situations where there doesn't seem to be a real understanding of, to talk about the filtration situation that Rob was talking about, that this requires that sort of, you can't just pour DEF in a boot and then pour it into the tank. What's the best way to educate the community, or is it a case that for the end users it's going to take them having problems for them really to hear those messages?
For us, again, that one step removed from the end user customers, but we certainly feel we've got a role to play to support our customers in that, because I know I've go to a lot of events outside the emission industry, but in the heavy duty industry, and there's a lot of eye rolls when you hear you work for the emission control industry about, just, broad brush that these systems don't work. And, I think we heard a lot of reasons why sometimes after treatment is a symptom of another problem, and it's not just, replacing a DPF, clogged DPF will solve your problem, but, we take it very seriously to how we can support our OEM partners on that education process, because as you pointed out, it's really important.
Jamie?
So as far as the knowledge for the customer, I know they have manuals that describe the proper use, and probably like most people, I know I don't read my user manual when I get a new car, things like that. Beyond that, I'm not really sure what we do from a marketing and kind of service perspective to help develop that knowledge. I do know through our field testing programs where we partner with different customers that it does give us a lot of insight into how they're operating and how they're using the vehicle. They learn a lot about the technology up ahead of the time that they'll have it in use with their end user. So it does create that opportunity for both of us to learn and try to make improvements. And obviously from a technology development perspective, we're always trying to figure out what could go wrong with the system and how do we foolproof it so it's not a concern.
Deep, you tend to work with much larger machinery, and I guess in my experience, the bigger the investment, the more attention on the rail side, on the marine side, on big frac rigs and things that use very large engine, they tend to be very focused on, or more focused than perhaps the guy who owns a skid steer loader, on proper maintenance techniques and things like that. Do you get a sense that they understand the criticality of that?
They are starting to. So one of the things for the marine application, they do feel comfortable that the engine remains very similar to the predecessor engine. That really helps them because now they only have to learn the after treatment port side of it. But one of the things we have been, since we are part of the Caterpillar family, we have started integrating a lot of the monitoring panels and everything into our portfolio, which actually is gonna, so one of the things our customer have started asking is they want to visualize every sensors what we are reading into some form of their panels, and that's something, one of the things they are starting to learn about it and not completely depend on the OEMs when they come and try to troubleshoot it. Most of our customers have a very good training centers and we work very closely with them. Our dealer network is very strong in that aspect too. We always working very closely with them.
There are a couple of technologies that we've seen over the years that in some way showed a lot of promise that you don't hear as much about anymore. Specifically NOx adsorbers, which I think still have some application in some light-duty automotive type markets. There's been several companies that have been active in working on development of things like solid SCR. What are the chances that there will be any new emissions or after-treatment technologies sort of like those that we'll be seeing, without giving away the store for either Johnson Matthey and Cummins Emission Solutions? Are there things in the works that are going to be specifically different than what we're seeing right now?
I know I'm more on the downstream end of you have 3 years to take this and get it into the hands of customers. So that's not really come to my level. I know a lot of the work that we're still seeing is just trying to optimize the packaging design and how well we're using the technologies that exist today. But I don't know beyond that what may be coming.
Dave?
Yeah, no question we're innovating on this front. I think in large part it's typically a new regulation is the driver of that, but we're always prepared that in case somebody comes with a more cost-effective solution midstream. But I think, new regulations in Europe on the light-duty side have been driving some P&As into the market. You saw yesterday the Southwest on-highway program, in advance of a ultra-low NOx rulemaking, is incorporating a P&A. I think on the off-road side, we're still in implementation and optimization space, but you never know.
So watch that space at Johnson Matthey. You mentioned how in many cases technology is driven by rulemaking. And I guess one of the aspects of Stage 5 regulations talks about a particle number standard. And we've heard today that probably that may not be part of any potential standard in the U.S. But I guess if you could explain, does that cause any challenges for manufacturers here who are trying to build products, either components or engines or machines that are built here maybe and exported to some places that do have that? I guess what's the difference from your perspective in having to regulate to a particle number as opposed to just a mass flow?
Well, I know for us that the Euro market is distinct from that perspective, that like for a mid-range product that we have a DPF there and we won't for our Tier 4 final product. So the benefit is that, as long as it's relatively in line with the same type of requirements, the technologies that we're integrating and producing for Stage 5 could easily be ported over if there is a Tier 5 or something coming along those lines. But we're also not getting rid of our Tier 4 final product that's out there, so even if there's no driver to force them to change, they're not going to have to go to a DPF-based technology, and they can just continue to use that.
Anybody else? Do you, a question sort of somewhat related to that, there is no, and here's a plug for my publication, in our September issue, we asked EPA what's the likelihood of a Tier 5 regulation, when might we see that, are you working on that, and got a wonderful governmental answer, which meant that no, we're really not going to say anything now, but from your perspective, do you feel that a Stage 5 regulation is inevitable? Is there any way, without knowing what a specific regulation is, you can kind of be ready for that? Or do you have any inkling when we might see activity from EPA?
Yeah, no, I mean, I don't think it's high on their priority list right now, and I think a critical difference is that a lot of our mobile source regs in the U.S. is driven by NAAQS compliance, and I don't think they view PM NAAQS nationally as a compliance issue right now. A lot of regions of the U.S. are coming into PM NAAQS compliance, including California. So, and there could be other drivers, but until until PM NAAQS is tightened, or there's an incorporation of ultrafine particulate NAAQS at the national level, I mean, I don't see it on the short-term agenda.
How about from both the Jamie and Deep, what do you think? Do you see, and is there any way, do you see any likelihood, and do you prepare for something like that ahead of time, or how?
You mean mainly from the PM perspective, or are
Yeah.
you talking from NOx and PM?
I guess both. How's that?
Well, we're just settling into the Tier 4. I think we need some form of a breathing room before we go into Stage 5. But I've been hearing the heavy-duty presentations from both EPA and CARB yesterday, and 0.2 NOx. It's going to be a fun ride ahead of us. I mean, we might need a locomotive just to carry the after-treatment system behind the actual locomotive, but we'll figure it out. I think one of the there's a lot of pressure on Dave on creating an after-treatment system or the catalyst which can meet the size and the requirements, but I cannot comment on the PM at this point.
Yeah, I think in general, just from my perspective, that if we look at what's happened with Stage 5 and on highway, we could have PN requirements that come across at some point. We haven't really spoken at all about service and diagnostics, but onboard diagnostics is a strong piece of what is part of on highway. We never know if that's going to come across to off highway. Those are all some challenges, and even, greenhouse gas emissions, those things that are playing a role in on-highway, we're developing and being prepared for those. So if they do ever come to off-highway, at least we'll already have some of that experience and be able to kind of have a step forward in trying to meet those. But as far as if and when, just kind of guessing like the rest of us. So.
Yeah, that's one of the questions I had, is that I have to believe that regulators being what they are, at some point we will see an attempt at formulating greenhouse gas emissions standards for non-road applications. It just seems to make sense. They're another mobile source, and again, regulators got to regulate. Fish got to swim, birds got to fly. So if they see mobile sources that are emitting greenhouse gases, I think at some point that's pretty likely, but that will be a really interesting process, I think. The red light is flashing. We'll take, if anybody's got any other questions. Anybody? Oh, here we go.
This is a question for Deep. Like yourself, I tend to deal with the bigger engines than the smaller 15 litre less things. What I want to understand from your point of view is the diversion in the market for Tier 4 on marine and loco between EGR with GE and EMD, and then SCR with Cummins and some of the CAT 3500 series. Why do you think that diversion is occurring?
So your question is why railroad have a EGR solution?
In both marine and locomotive, why the diversion in technologies?
So the railroad wanted a urea-free solution. And that's mainly because of the DEF infrastructure, which for the railroad, they have to implement the DEF infrastructure. On highway, it's slightly different. The trucking industry do not have to create the infrastructure. So from the very beginning, the railroad requested or basically asked for a non-urea solution. And both EMD and GE actually worked towards it. The marine side of it, they actually want a non-EGR solution, and the one big reason is because of a high reliability. They have heard a lot of horror stories of high EGR, but you need to go to that tier 4 level of NOx. And you might have some EGR plugging and everything where the engine might derate when it's in the middle of an ocean. So the marine industry was very favorable towards a marine solution. I know our competitor GE has been trying to market the EGR solution for the marine application. There are a few, but we'll see how that goes into. The other thing is the EGR solution also needs around 50 to 60% more heat rejection, which is quite a bit challenge when you are in the Gulf Coast where you do not have any more heat rejection capability. So that's one of the other reasons why a lot of marine application wants to go for a urea or a DEF solution. One other big reason is most of these marine solutions are owned by power plant companies who actually, or at least the inland river waterways, who uses urea for their own the stationary power plants, and they move urea all along. So for them, that DEF is readily available. So.
Any other questions? Well, thanks to our panelists, and thanks again to Integer for putting together an interesting and informative event.